Hi, everyone. So we've done derivatives and integrals of exponential functions with base e, but we haven't talked about what happens if our base is some other value, like a 3 or a 5 or an 8. So there's just a rule that we need to follow to find these derivatives, and that rule says if we have some exponential function, y is equal to a to the u power, then our derivative, y prime, is going to be equal to, and you'll notice that this kind of seems familiar from our base e, is going to be our exponential function a to the u, but then we need to take the derivative of whatever's in our exponent. So I'm going to write that as du dx. And then there's actually a third piece here where we're going to multiply by the natural log of whatever our base number is. In this case, our base would be a, so we'd be multiplying by the natural log of a. So we'll look at just a couple of quick examples, and then in the next video, I'll talk about the integrals of exponential functions. But using this formula, if we want to find the derivative of f of x is equal to 3 to the x, then my f prime of x is going to be, again, just the 3 to the x multiplied by the derivative of your exponent, which again is kind of like the chain rule here. In this case, our derivative of our exponent of x is actually just 1 times the natural log of our base, which would be 3. And I would just clean this up to make f prime be 3 to the x times ln of 3. And it's really as simple as that. So if you look at the next example, we'll look at what happens when there's something in the exponent there. So our f prime here is going to be 5 to the pi x times the derivative of whatever's in the exponent. So derivative of pi x would just be pi times the ln, or natural log, of our base 5. And you could rewrite that if you wanted to rearrange these. Again, multiplication is commutative, so it doesn't matter. Maybe you'll see it written as the pi first times 5, pi to the x times the ln of 5. But again, it just doesn't matter the order that you write them in. Next basic example. So if I have f of x is equal to 8 to the 4x to the 5th power, my f prime is going to be, to keep everything the same, so 8 to the 4x to the 5th, multiplied by the derivative of the exponent, so 20x to the 4th, times the natural log of the base of 8. And again, you could rewrite those in any order, but there's our derivative there. Last one, a little bit trickier, but really not too bad. So we want to find the derivative of f of x equal to 5 to the square root of x. So my f prime is going to be 5 to the square root of x. Then I want to multiply by the derivative of the square root of x. So remember that the square root of x is just x to the 1/2. So derivative of x to the 1/2 is 1/2 x to the negative 1/2 times the natural log of our base 5. And I am going to clean this up a little bit because this looks a little nasty the way that I wrote it. So we can say that that in the numerator is 5 to the square root of x times the ln of 5. And in the denominator is going to be our 2. And I'm going to drop down that x to the 1/2, and I'm going to write that as a square root of x. So there's our f prime of x. So I'm going to make another video for the integration of exponential functions, and then you guys will have some practice on these.